Okay, so today we're going to start our Unit 3, okay, which is going to look at graphing. We're going to start with the basics, graphing linear equations. Okay, so a linear equation in two variables is just an equation that can be written in the form ax plus by equal to c. This is what we consider to be standard form. Okay, so ax plus by equal to c. Where a, b, and c are all real numbers and the graph is a straight line. Okay, that's why it's called the linear equations, because the graph is going to be a straight line. So examples of linear equations, okay, it could look exactly like that. So negative 2x plus 3y equals 7. Okay, whatever those numbers are, we've got the x plus the y plus the equal to the c. Okay, but it doesn't say that a, b, and c have to be actual numbers. They can be, well, let me rephrase that. It says that a, b, and c are real numbers, which means that a, b, and c are allowed to be 0, is what I'm trying to say. So that means that we don't necessarily have to have an x. I could just have 4y equals 9 or something like that. Okay, I could also not have my y value could have a 0 in front of it. So we could have x equals 12. That would be a linear equation as well. C can also be 0, so I could have something and it'll probably look like 5x equal to negative 7y, something like that. Okay, these things can move around. That y could have been on the left side, the x could have been on the right side. Doesn't really matter. But the point is that when I'm looking for linear equations, the exponent has to be 1. So the exponent on all of those, whether there's an x and a y, just an x, whatever the case may be, the exponent on x and y is always 1. So for example, a non-example here, if my y was squared or cubed or any other exponent other than 1, okay, that's not linear. Same thing with the x. If I have like, I don't know, 3x cubed equals 9. Okay, the fact that there's an exponent of 3 on there means that it is not linear. The one that gets people a lot is if I have something like y is equal to 1 over x. Okay, remember when we talked in the last unit, an x on bottom is not the same as an x on top. This actually has a negative exponent here when it goes to the bottom. So 1 over x is not the same thing as having just an x. So if the x is in the denominator, it is not a linear equation. Same thing with y. If y is in the denominator, it would not be linear as well. And that's basically what this little sentence here says. You can kind of go through and read it, but if the exponent is not 1, then it is not linear equation, okay? This says we can have just an x or y. I already talked about that. For instance, if I wanted to write y equals 7 in standard form, I could easily make my a 0. So 0x plus y equals 7. That is in standard form. And 0x would just disappear. It'd be the same thing, just written in standard form. So I can use 0 to put a variable back in to write it in standard form. Alright, so identifying them, it's literally just trying to figure out if these things are linear by looking at those exponents on my variables. So here my exponents are 1 and 1 on both of those, so that would be a yes. Okay, here I've got an exponent of 2. That would be a no. That is not linear. Okay, same thing here, x and y, exponents are both 1, so that would be a yes linear. Here, exponent is 1. We don't have to have a y. Okay, the exponent is 1, so that would be a yes also. And here I've got that exponent up there, so that would be a no. And it's really that simple as far as identifying whether these things are linear or not. Now, graphing linear equations using coordinate points. I want to point out that when you are taking your test, it will say you must graph linear equation by using coordinate points. Okay, so you can't use slope-intercept form to graph them and think that it's going to be okay. If it says to graph by coordinate points, you have to use this method that I'm about to show you. And the reason why we're going through all of this, although we can, with linear, we can do slope-intercept, but we're going to do a lot of graphing later on where the slope-intercept is not going to be helpful because we're not going to do linear equations. We'll have other polynomials that we're going to want to graph later on, and we want to be able to create tables and make coordinate points so that we can actually graph those. Okay, so xy, this is what a coordinate point is. So xy is a coordinate, helps if I can spell it, coordinate point. Okay, the x is the x coordinate and the y is the y coordinate, of course. And we count to the right or left Okay, right if it's positive, left if it's negative using the x coordinate. So x goes side to side. And we go up if it's positive and down if it's negative using the y coordinate. Okay, so y is going to be my vertical movement. Now we can graph linear equations using coordinate points that are on the line, and we're going to use tables to help us do that, which is what we are about to do. Let me actually zoom this out a little so I can look at the whole thing at the same time. I don't like this moving back and forth thing. I think... Okay, sorry about that. So, make a table for the following equation. Find at least 3 coordinate points. Okay, so we're going to create a table. So, since they want me to make a table and they don't give me any values to work with, I am going to pick my own x values. Okay, we are going to pick our own x values. We're going to take those and plug them in to get my y value. So, for instance, I'm going to use the same ones over and over again. It doesn't matter. I could pick x as 3 or 4 or 1 or -1 or 0. It doesn't really matter. I always use basically the same ones. I start with x as -1. Okay, I'm going to use -1, 0, and 1. But you can use any of them that you want. And I'll show you a few extras if just to kind of get the idea. Okay, but here's my table. I've got my x and my y. So when x is -1, we got to figure out what y is going to be. So I'm going to take -1 and plug it in. So 2 times -1 plus y is equal to 5. That would be -2 plus y is equal to 5. So plus 2, y is equal to 7. So that means that when x is -1, y is 7. If I was writing that as a coordinate point, my point would be -1, 7. Okay? This is table format, -1, 7. This would be coordinate points. Okay, -1, 7. So it just depends on how they're asking you to do it. If they tell you to write coordinate points, then you need to write them out like this. If they tell you to make a table, you need to write it out like this. But it's the same information, essentially. Okay, so then I need to do another one, so I'm going to use x equals 0. A lot of people don't like to do x equals 0, but it's actually the easiest one, because once I plug in 0, well, 2 times 0 is just 0, so I get y is equal to 5. So when x is 0, y is 5, and then I'm going to use 1. Okay, so if I plug in 1, 2 times 1 plus y is 5. 2 plus y is equal to 5. If you need me to slow down, it's real simple. You just hit pause, and you go back, and you do it again. Okay? It's the nice thing about the videos is you can always just pause me. You could even mute me if you don't want to listen to me, and just watch what I'm doing instead. So, when x is equal to 1, y is equal to 3. Okay, when x is equal to 1, y is equal to 3. So there's 3 coordinate points. Now you can do more than that if you wanted to, especially when we get to graphing. Some of you might want to try to pick another point. Okay, but that's all that's required. I'm just going to do one more just to show you that it doesn't really matter. Okay, I kind of picked 3 in a row, but they don't have to be in a row. I can do x is 4. Plug that in. 2 times 4 plus y is 5. 8 plus y is 5. Subtract the 8. Y is equal to -3. So when x is 4, y is -3. So that would work as well. Okay, we just wanted 3 points. Again, this is table format. If they asked for ordered pairs, then I would go and list them all like that with the parentheses. Hit the pause button, try the on your own, come back, see if you get the same answer. I'm going to keep going. Here we go. So I'm going to do x's. I'll choose different numbers this time. I'll go -2. I like to throw some negatives and some positives in there just to see what they're doing when it's negative. So 3 times -2 minus y is 6. So -6 minus y is 6. Add the 6 over. -y is equal to 12. Remember, don't leave that negative y. If you divide by -1, that would make y equal to -12. So when x is -2, y is -12. I'll just pick 0. Again, you can use any numbers you want. I like to use 0 because it's easy. 3 times 0 minus y is 6. So 0, so I get -y equals 6. So divide by -1. So y is equal to -6. So when x is 0, y is -6. I need one more. I'll go with x is 1. 3 times 1 minus y is 6. 3 minus y is 6. Subtract the 3. negative y is equal to 3, which means that y is equal to negative 3. So when x is 1, y is negative 3. Okay, again, you can use any numbers that you want. I could have an infinite number of things here. It's not going to be wrong unless you miscalculate it, okay? So you could pick 5 or 7, or if you feel like picking 57, you can. It doesn't really matter what you choose. You will just choose 3 x values, plug them in one at a time. Don't plug all 3 in. That doesn't even make sense. Plug each one in, find a y value. So when x is negative 2, y is negative 12. That is an ordered pair. So if I were to graph that, I would go to negative 2, negative 12. That's how that looks, and we'll do that in a second. Okay, so then graphing ordered pairs. Just to make sure we all remember how to graph ordered pairs, we went ahead and threw this on here. So if I want to graph an ordered pair, I have to remember first of all that this is my x and this is my y. Okay, it's always in alphabetical order. This is my x, this is my y. My coordinates, this is the Cartesian plane, so this is my x-axis and my y-axis. Okay, you have to know those. Those are just things that you should know by now. Okay, we're in Algebra 3. You need to know that this is my x-axis and this is my y-axis. If you don't, just study it. It's just 2 little things to remember. Okay, this thing's going to go alphabetically. So then, this literally says when x is 1, y is 3, so I count over 1 in the x direction and 3 in the y direction. I plot my point. I do the same thing here, so when x is 0, okay, well right here is where x is 0. I don't move. Okay, I don't go left or right because it says don't go left or right. And then y is negative 5, so that's down 5. 1, 2, 3, 4, and 5. Plot my point there. One more to do. When x is negative 2, y is positive 1. Okay, and that's what it is. Now on here, they said graph ordered pairs. Okay, we're all tempted to go ahead and start drawing lines between them, but they specifically said graph ordered pairs. Graph those 3 points. I graph those 3 points. If I connect the dots, that means that I'm not just graphing those ordered pairs they told me to. I'm actually graphing every single number between each of those points. So I am not going to connect those dots because it specifically said graph those 3 points. That's what I did. Okay? Do the on your own. Make sure it's the same. You could probably do it at the same time as me. You probably don't even need to do the pause this time. Okay, so x and y. So when x is negative 3, y is positive 4. 1, 2, 3, 4. There is negative 3, positive 4. Plot my point. When x is 3, y is 0. Be careful with these. For some reason, once a 0 gets in there, people start to go a little backwards. It is still x, y. So we go 3 in the x direction, 1, 2, 3, and 0 in the y direction. So that means you don't go up or down. You just stay right there. And then we've got x is positive 2, y is negative 3. So 1, 2 to the right, and then 1, 2, 3 down. And there it is again, no lines. If you connect them, you're going to lose points because that said graph those points. That's what I did. So now we're going to put those 2 skills together. Graph the equation, negative 5x plus 3y equals 15, by finding and plotting coordinate points. Okay, so first I have to find coordinate points before I can plot them. Okay, that was the very first thing I did. So to find coordinate points, I'm going to choose x values. Again, I can choose any ones that I want. Okay, I'm going to start with x is 0 because that's always the easy one. So negative 5 times 0 plus 3y equals 15. Okay, negative 5 times 0 is 0, so I get 3y is equal to 15. Divide by 3, and y is equal to 5. I will point out real fast before I even move on that you could choose y values if you wanted to. I could pick y values and solve for x, and that would work as well. It's just I've always just done x's, so that's kind of what I do. But you could very easily choose y values and plug them in and get your x values also. So here's one ordered pair. So when 0, or coordinate point, same thing. When x is 0, y is 5. So there's 1. X is 0, y is 5. 1, 2, 3, 4, 5. Okay? But I can't draw a line with just one dot, so I have to pick another one. I have no idea which direction to go. So I need to pick another point. So I'm going to go with x is equal to, let's just say I choose 1. Okay, this is not going to work out pretty, and I know that, but I want to show it to you. So let's say I choose x is 1, and I plug that in. I get negative 5 times 1 plus 3y is equal to 15. So negative 5 plus 3y is equal to 15. Let's add 5. 3y is equal to 20. Divide by 3. Okay, well 3 doesn't go into 20 evenly. So 20 over 3 is my answer, but that's kind of hard to graph. What's easier is to convert this. 3 goes into 20 6 times, and I would have a remainder of 2 over 3. So changing it to mixed numbers. Remember, we did that in the very first unit. If you don't remember, go back and look at the notes for that. Okay, if you don't have the notes, it's okay. They're on my website. Just go down. You're already on my website. Just find Unit 1 and look at the converting notes. Okay, so what this says is when x is 1, y is 6 2/3. Now at this point I have two options. I can graph that, or I can pick another value until I find one that works out pretty. I'm going to go ahead and graph it, because why not? Okay, so it's not as bad as it really looks. When x is 1, so this is still my x, this is still my y. So when x is 1, y is 6 2/3. So we go up 6, 1, 2, 3, 4, 5, 6. And 2/3. So that's almost all the way to 7, but not quite. By the time I put that big old dot in there, it takes up half the space anyway. So it's going to be approximate. But as long as I don't go all the way up to 7, then I'm doing pretty good. Okay? So then we're going to do, I could technically draw a line here. Right? I've got 2 points. But when I'm doing these, I am always going to choose 3. Okay? Choose 3 x values, and you might want to star that. The reason being is because even if my 2 lines are wrong, or either one of those dots is wrong, I'm still going to get a straight line, right? Because I can draw a straight line through 2 points pretty easily. Okay? Now the problem is they could be wrong. Now if I choose a third point, and I calculate 3 points, and all 3 points end up on the same line, then I probably did it correctly. Okay? Because the likelihood of me calculating 3 different points and them all and doing it wrong, but them all ending up on the same line is pretty slim. However, with just the 2, then I won't know. So that's kind of what we're looking for. That's why we choose 3 points, is because we want to see if it really does make a line. 2 points, we don't know, because 2 points I can make a line, whether it's right or wrong. But 3 points, okay, if it's not a line, if they don't line up in a straight line, then I did something wrong. Because these are linear equations, so they should graph to be a straight line. So if the points do not line up in a straight line, then you know you are wrong, and you need to go back and check your numbers. Alright, so I'm going to pick another one. Now, let me talk about how to pick better numbers, because we don't always want to graph those ugly little fractions, okay? But that is, you can graph them, and that's how it's done. It's not a big deal. You just do them. But let's say I wanted to try to pick something that will work out nicely. Well, you got to imagine that up here, I'm trying to find something divisible by 3. Okay, so I want it, because at the end, I'm going to have to divide by 3. So when I move this number over, I want it to be divisible by 3. So for instance, I can also kind of look here. Because if you look here, I can kind of tell that if these numbers are correct, then I'm going in this order. And if I go too far to the right, well, I'm going to end up here outside of my graph. I don't want to go outside of my graph. I kind of want to go this direction. So what I'm going to do is I'm going to look, well, what can I put in there? If I put in 1, or -1, I'm going to get +5. Subtract, I'm going to get 10. That's not going to work. If I put in -2, that gives me +10. Subtract it over, I get 5. That's still not going to work. Okay? Put in a -3. That's going to be +15. Well, when I subtract that, I get 0. That works. That's going to be good. So x is equal to -3. So I get 5 times -3 plus 3y is equal to +15. -3, I don't know why I wrote 13. That's horrible. Times -3. So -15 plus 3y is equal to +15. Add your 15. Oh, sorry. It was -5. I was like, I'm missing something. I'm so sorry. Let me try that again. Okay, so I picked -3 as my number. X is -3. My formula was -5 times x, so -5 times -3 plus 3y equals 15. Now I have it written down correctly. -5 times -3 is +15. Subtract 15. That's much better. And I get 3y is equal to 0. Well, if 3y is 0, when I divide by 3, y is also equal to 0. So there's my other coordinate point. X is -3 and y is equal to 0. So when x is -3, y is 0. Okay, and now you can kind of see when you go to line that up, which using your ID is a very good way to do that, by the way. So when I go to line that up, you can see it lines up in a really nice, pretty, straight line. Now these, I do connect. Okay, because they asked me to graph that entire equation. And you have to imagine that I picked these x values, and I could have picked any x value from any direction, from negative infinity all the way up to positive infinity. I could have chosen negative 200, and I could have plugged that in, and I'd have gotten a value. I wouldn't have been anywhere on this little bitty graph, but it would have still landed somewhere on this line. Any x value I choose will land on this line. So if I choose x as negative 1, I'm going to get an answer that's going to be 1, 2, 3 something. Okay, it's probably going to be, it's not going to be pretty. It'll be 3 something, but negative 1, 3 something. If I plugged in negative 1, actually let's just do it to show you. So x is negative 1. Negative 5 times negative 1 plus 3y is 15. So I get positive 5 plus 3y is equal to 15. Subtract 5. 3y is equal to 10. Divide by 3. Y is equal to, well, 3 goes into 10 3 times with 1 remaining. So x is equal to negative 1, positive 3 1/3. Okay, so if I would have checked negative 1, if I would have taken negative 1 instead, when x is negative 1, y is 1, 2, 3 1/3. What do you know? That happens to fall right on my line. Okay, and that's kind of the whole point. No matter what x I choose, if I plug it into that equation, I will land on this line. So that's why I have to draw this, and I use the arrows to show that it goes on forever in both directions. You need to use those arrows as well. Okay, infinitely to the left, infinitely to the right. It will continue on in that pattern. Alright, I would try that very last one. Hit pause, give it a shot, see if you can get the correct answer. Okay, come back, see if it matches up with mine. Again, you might not choose the same numbers, but your line should be exactly the same as mine. So here we go. X is equal to 0. 2 times 0 minus 3y is equal to 6. Negative 3y is equal to 6 divided by negative 3. Y is equal to negative 2. So I get 0, negative 2 is my first one. X is 0, y is negative 2. And I plot as I go so that I can kind of see where I'm at on my graph. Because again, if it starts to get too high, then I'm going to go to the left instead. So let's just do x is 1, because I know a lot of us probably stayed close. So 2 times 1 minus 3y is equal to 6. 2 minus 3y is equal to 6. Subtract your 2. Negative 3y is equal to 4. Divided by negative 3. Y is equal to negative 4/3. So when x is 1, y is negative 4/3. So when x is 1, oh, sorry, let me convert that. My fault. I usually just graph them from there, my fault. But we should probably convert it. It makes it easier to see. So 3 goes into 4 once, it's negative, and I get 1/3. So negative 1 and 1/3. Okay, so when x is positive 1, y is negative 1 and 1/3. So it's going to be just below negative 1. Okay, we're going to go down a little. Alright, so I'm going to pick one more. I'm going to pick one that actually works out very nicely. Okay, so again, I'm divisible by 3, so I'm going to try 3, see if that works. X is 3. Plug that in. 2 times 3 minus 3y is equal to 6. 6 minus 3y is equal to 6. Subtract that 6. Negative 3y is equal to 0. Divide by negative 3. Y is 0. So when x is 3, y is 0. Okay, x is 3, y is 0. What do you know? It's falling into line with all of those. I'm going to do one more just for the fun of it. So also, and again, for those of you thinking, can I just put it in slope-intercept form and draw it and then write down points? That's not going to work. You have to show this work. You have to show this work on your homework. You have to show that work on your test. Alright, let me pick one more. So positive 3 works, so I'm going to say negative 3 will probably work. So let's try negative 3. 2 times negative 3 minus 3y is 6. Negative 6 minus 3y is 6. Add your 6 this time. Negative 3y is positive 12. Divide by negative 3, and we get y is equal to negative 4. So when x is negative 3, y is negative 4. X is negative 3, y is negative 4 is right here. And what do you know, those things all line up very pretty. I'm going to draw my little line using my ID because it's the easiest way, because I already have a straight edge right there. Why not use it? Okay? And then I drew my line. Again, you have to draw that line. If you stop and you just plot points, you lost a lot of points on your test. So make sure you draw the line, show your little arrows to show that it's infinite in both directions. And that is the end of basic graphing. Good luck.